So for this week's tutorial, we'll be looking at chi-square analyses. Okay, so SPSS is open here, and we have two categorical variables because that's all we need for chi-square. So if we look a little closer, we can see that we have, gender and music preference, where ones and twos indicate male and female, and then on the music preference side, we have 1 for rock, 2 for pop, 3 for country, and 4 for techno. So what we're going to test is whether there's a relationship between gender and music preference. So to do this, we need to look at a chi-square analysis since we have two categorical variables and we're looking for a relationship. So this is a very simple analysis to run. What we need to do is do analyze, descriptive statistics, and then crosstabs. Okay, so analyze, descriptives, crosstabs, and we'll click here. And then essentially we have the choice of how we're going to build our table. So we have our row variables and our column variables right here. So for example, if we want to put, if we want our table to be one way or flipped, that's all that's going to change here. So if you put gender on the row section and music on the other, it's going to give us one orientation of the table. If we flip it, it's going to give us the opposite, but it's not going to change any of our results. So I'm going to put the wider one, so the one with more levels, so more categories on the column selection, and then gender will go on the other one because it only has 2. So we have a few selection or variable or options that we need to select. So we'll just go through each of the tabs. We don't need anything under exact. Under statistics, this is where we're actually going to ask our SPSS to give us the chi-square. So we just need to click the box right here. And then everything else we can actually just leave. So that's under statistics. In cells, it automatically is going to give us the observed. However, if you do want to see what the expected count is for each cell, we can also click this. And then in order to get our residuals, so in order to test whether or not they are significantly different than, or there is a significant difference rather between the observed and the expected, we will click on standardize. And just to make sure the language is consistent between the lecture and SPSS, expected is the equivalent of model. Okay, so this is what the model is estimating. So we'll click OK here. And format, we can leave it, and actually under bootstrapping we don't have anything to do. So all this being done, we can click OK, and we get our results. So the first thing we get is a table just giving us a summary of how many participants were included. So in this case we had 100, and everyone was included in the analysis because they had data on both variables. So there was no missing data, and this would have been the adjusted total once you took into consideration the missing data. But in this case, everyone was a participant. So now we have our table, and this looks a lot like the one we calculated in class. However, it also has the standardized residuals built right into it. So what we can see is that we have our males and females here, and then we have rock, pop, country, and techno right here. So the count is what we actually see in the data. So we see 5, 5, 14, 26, and 19, 17, 7, 7. So we can see there's something a little bit different going on for the males and the females. The expected count is what should be expected, or we should expect to see based on just the distribution of frequencies. So this is our model's estimate of what should be there. So we see we have 12, 11, 10.5, 16.5, and same thing here. And then what we have right under it is actually the standardized residual. So what that's telling us is whether there is a significant difference between the observed and the expected. Now one thing to note is that the larger the cells get, so in terms of there are more frequencies in each cell, it's going to take less of a difference to see something significant. So just because you see significant differences here doesn't mean that overall there's enough of a difference for it to be significant. So you need to look at the chi-square test, and what we actually see here is the chi-square statistic right now. So this is the value. So we have 27.985 in our degrees of freedom. So if you recall, the degrees of freedom is calculated by taking the number of levels for one variable, minus 1, and multiplying it by the other variable, minus 1. So in this case, gender minus 1 is 1, and music preference minus 1 is 3, so we had a degree of freedom total of 3. So a chi-square value of 27.99 for 3 degrees of freedom is significant. So we can conclude that there is no issue there. And if you recall, one of the assumptions we do need to look at with when conducting this in SPSS is that there are at least 5 observations in the expected frequency count. So we're not so concerned about the fact that these have 5 here. What's more important is that it's estimating that there's 5. Okay, so that's the important one. So the expected count for all of them is above 5, so that's not an issue. So now that we know we have a significant test, we can now look a little bit closer at the standardized residuals. And what we can conclude is that for rock, there was an unexpected difference for males and females. So it looks here that the males were on the low end, so they only had 5, whereas they expect to have 12, and that's significantly different. And the females were on the high end. They had 19, and they should have been around 12. The rest of the relationships here are the same. However, once we get to the techno, we see that the males unexpectedly liked techno because we were expecting something around 16 or 17 and we had 26, and the females really didn't like it. So same thing here. So you will notice that the table is always going to be split rather equally here in terms of the residuals when you have only 2 groups, but as soon as you add more levels to a variable, you will start to have effects that show up in one part of the table and not others. So, for example, if this variable here, it had 3 levels, it would have been possible to see that one was significant, but the other 2 were not. But as long as you have 2 levels, it's going to be pretty much a mirror image of the table right through. So that's actually all you need to run the chi-square analysis in SPSS and the standardized residuals, and how to conduct or calculate rather the standardized residuals in order to conduct the follow-up tests. So that is it for this week. Thank you.